In this first example, we see a Lewis acid reacting with a Lewis base. When we draw in the reaction arrows, we see the movement of two electrons, the electron pair. The Lewis base donates the electron pair, whilst the Lewis acid accepts the electron pair. But that isn't the only definition that will work in this example. When we think about a Bronsted Lowery base, that will accept a proton, whilst a Bronsted Lowery acid will donate a proton. So the first example shows Lewis acid and base, and also Bronsted Lowery acid and base. In our second example, we also see the reaction of a Lewis acid with a Lewis base. Drawing in the reaction arrow that shows the movement of the two electrons, the electron pair, we see that the Lewis base is donating the electron pair, whilst the Lewis acid is accepting the electron pair. But that is where we must stop. This reaction does not involve the movement of a proton, and so we do not have Bronsted Lowery acid, nor do we have Bronsted Lowery bases involved. We've talked about Lewis acids. What about Lewis bases? Well, a Lewis base will donate an electron pair. But what form will that electron pair come in? Here are some examples of Lewis bases. What do they have in common? Well, they all have lone pairs. The lone pair can act as an electron pair. But that's not all. The lone pair shown here are neutral species. But it's also true where the atom is negative. But lone pairs aren't the only examples of Lewis bases. They're certainly very common, but we can also look at, for example, a double bond, a pi bond, being a Lewis base. Here, the electron pair is one of the bonds of the double bond. The double bond changes to become a single bond, and those two electrons, the electron pair, can now move towards the Lewis acid.